Bismillah ar-Rahman ar-Rahim. This is Muhammad Suge Hirsi, your science teacher. Welcome to our online class for grade 8 students. Today our topic is balancing chemical equation. Balancing chemical equation. How we balance our chemical equation. Chemical equation contains two sides within arrow. This side is called left side, and the other side is right side. To balance this equation, left hand side must be equal to the right side. At that time, our equation is balanced. Okay, let us go on. Let us start our lesson. First of all, we have to take the definitions. What's a chemical equation? Chemical equation is the symbolic representation of a chemical reaction in the form of symbols and formulae. Chemical equation, we use symbolic representation. We use some symbolic that represent the actual atoms. That atoms, they are in a chemical reaction. They combine together. Chemical reaction means atoms combine together in the form of symbols that we wrote earlier and formulae. Look at this below. This is glucose, C6, H12, and O6, carbon, hydrogen, and oxygen. Plus, we combine another oxygen. Our result, this arrow means the result is forms carbon dioxide plus water. This is chemical equation, which contains reactants and the products. Reactants, the raw materials that combine together to form forms our products. The products always lie on right hand side, and the reactants always left hand side. This is chemical equation. We use symbolic representation. This C represents carbon, and this H represents hydrogen. All of these atoms in this chemical equation are symbols which represent actual atoms. Right. What are the reactants and what are the products now? As we told before, the substance undergoing reaction, initial substances, the raw materials are called the reactants. They are the initial substance, the initial reagents of the reaction is called the reactants. And the formulas are placed on where? The left side. The left side. Always we write in a chemical reaction, we always write the reactants to the left side of the chemical reaction or of our equation. What are the products? The substances generated by the reaction are called the products. The substances that will be the result of the reaction is called products. In a short way, we can explain this. The result of the reaction. The result of the reaction is called the products. Or you can say the substance generated by the reaction are called the products. And the formulas are placed or written on the right side of the chemical equation. Right. Now we defined the reactants and the products. Let's look here. This is in general chemical equation. This arrow tells us the center of the chemical equation. This arrow means yield or forms. Okay. This is carbon dioxide plus added together water. Our result will be, this is our glucose plus oxygen. This C stands for carbon and oxygen. All of them, they are carbon dioxide. That 6 stands for number of molecules. How many carbon molecules are there? 6 carbon dioxide molecules. And this 2 is called subscript and tells us the number of atoms. How many hydrogen atoms are there? 2 hydrogen atoms are there. How many oxygen atoms are there? How many oxygen atoms are there? How many oxygen atoms are there? 2 oxygen atoms in carbon dioxide. This arrow, as we told, means yield, forms, what the result will be when we add those molecules together. This G, S, L, another G stands for the state of matter. Tells us which kind of matter that this element is. State of matter. S stands for liquid. G stands for gas. And L represents liquid. So, carbon dioxide, the state of matter of carbon dioxide is G. And the state of water are liquid. And this is solid and oxygen is gas. So those letters, they tell state of matter. Right. In overall, these are the reactants: methane plus carbon dioxide, reactants plus another reactant, products. So that 2 is coefficient and it states or tells us the number of molecules. And these 2 students tells us what? Number of atoms, right? So the structure of the reactants, this is methane, internal structure of methane, and 2 molecules of oxygen, atoms of oxygen, another oxygen. So when we add together, we will get the product of carbon dioxide and water. Reactant side left and the product side right. Okay, so left side we always write the reactants and right side we always write the products. Plus means it separates individual reactants. As we seen before, this plus separates the individual reactants. You see? And this arrow separates the reactants and the products, left and right of the equation. Right, do you know that? The relative number of reactants and the number of product species are represented by coefficients. We have seen before, right? Wait. This 6 states for the number of molecules that lie on the chemical reaction. So this statement tells us what? The relative number of reactants, number of molecules, and the number of products always represented by the coefficients. Coefficient means if we write here carbon dioxide, the coefficient is written here. 6 means the coefficient of carbon dioxide. So it tells us number of reactants and the number of products is in this carbon dioxide. How many molecules are there? So this 6 states that. Okay. How we can balance the chemical equation? So the procedure is now start by balancing an element that appears in only one reactant and product. You can start one element that lie on the reactants and the products, right? Okay. Once one element is balanced, proceed. Go on and balance another and another, step by step, one by one, until all elements are balanced. Until you balance all of the elements in the chemical equation. Balance chemical formulas. Chemical formulas means chemical equation that you have by writing the coefficients in front of them. Only you write the coefficients in front of each molecule. Of them means of each molecule. If you have water, which is liquid, and you wanted to balance this water, you will write only or place the coefficients. You do not change subscript. Only you place or you write the coefficient. You write here something, not the subscript of the element. If you write here, we will see now. If you write here, you will change the nature of the molecule or the nature of a compound. If I write here 2, it will be hydrogen peroxide. It's not water. So I have changed the nature of the compound. Be careful. Only we write here the number that we wanted to balance our chemical equation. That number is called the coefficients, and we write in front of them. Do not add subscript. Yeah, we told now, because this will change the formulas. Formulas means the compound or the molecule. It will change the compound or the molecule. So be careful. Don't write the subscript or do not change the subscript of the compound. Then indicate the states of matter. You know states of matter? Which state of matter you have? Is it gas? Is it salt? Is it liquid? Or it is aqueous solution? G means gaseous substance. Substance that's gas. And S for solids, elements, atoms originate from solid. Or L, we use liquids. AQ, you write only the species elements in a solution in water. If a substance is mixed or are mixed in water, they become aqueous solution, AQ. If you have a solid, that solid must be soluble in water, and you mix or add into water, you will get aqueous solution, AQ. So that we use AQ for solution in water. So we write the state of matter immediately following the formula of the substance it describes. So add this GSL. If it is already written, no problem. You can go on. Right, I think we have example 1. Follow me carefully. We have to balance this chemical equation. Water, H2O, decompose it into hydrogen and oxygen. This is the decomposition reaction. We have studied before. Combination reaction, decomposition reaction, compulsion reaction. So many chemical reactions we took before. So water decompose into hydrogen and oxygen. Is it balanced? No. How we can count? How many elements are there overall in a side of reactant or the side of products? This is left side of our chemical equation, and this is the right side of our chemical equation. So R means the reactant, and this is our product. So right hand side, all we have only hydrogen and oxygen. Can you see any other element in here? No. Hydrogen, oxygen, hydrogen, oxygen. No other element. So in first column, you write how many elements are there by taking only one of each, hydrogen and oxygen. here tells us number of molecules in the reaction, and the subscript tells us number of atoms. We told before, be careful. So how many molecules? First we write number of molecules times number of atoms. Number of atoms. Okay. M means number of molecules times number of atoms in each reactant. How many molecules of hydrogen are there? Only you look at the coefficient. You look here. You look the coefficient. How many hydrogen atoms are there? Only one. Yeah, here is one, because of you cannot see other elements. Only we have one. If I write here H, it's hydrogen. So one molecule of hydrogen. Yeah, it's clear. So one, you cannot see one, but it states by one. One times how many atoms of hydrogen? 2. So one molecule of hydrogen times 2 atoms of hydrogen. One molecule of water, we can say one molecule of water times 2 molecules of 2 atoms, sorry, 2 atoms of hydrogen. 1 times 2 is equal to 2. Again, how many molecules are there? 1. 1 is here. How many atoms? The subscripts tells us the number of atoms. So how many atoms are there? 2 atoms. So 1 times 2 is equal to 2. At the product side, we follow on hydrogen scale. The product side, how many molecules of hydrogen are there? The product side is here. 1 hydrogen and 2 elements. 1 molecule and 2 elements. 2 atoms, sorry. We write here the molecules times atoms. Times atoms. So how many molecules are there? Look here. How many molecules are there? 1. 1 times how many atoms of hydrogen? 2. This 2 comes from there. This 2 comes from, look, that, right? So 2 atoms. 1 times 2 is equal to 2. When the number of products is equal to the number of reactants at that element of hydrogen, it's balanced. So 2 is equal to 2. 2 is equal to 2. So 2 is equal to 2. 2 is equal to 2. Is it balanced? Yeah. Yes, balanced. And now oxygen. We write here the number of molecules. Number of molecules. Number of molecules of oxygen. Number of molecules of water are 1. They are same because of here is 1. Only we count here. Let us try to raise these. Okay. Look now. How many? The coefficient. Look at the coefficient here. Number of molecules of water, same. We look the water, not by hydrogen and not by oxygen separately. only we look at the coefficient H1 times number of atoms in oxygen. Here the subscript is 1. So this is 2, but this is 1. So 1 times 1 is equal to 1. At the side of reactants. Now we have to look the side of products. The number of molecules of oxygen, because we do not need now hydrogen. We are in oxygen. So the number of coefficients of oxygen is 1 times how many atoms are there? 2. 1 times 2 is equal to 2. Are they equal? No. Number of reactants of oxygen is not equal to number of products of oxygen. So the number of reactants is 1, which is not equal to, this is not equal to the number of products, which are 2. Is it balanced? No, it's not balanced. So we have to balance oxygen. Hydrogen is already balanced, but we have to balance oxygen. Be careful. To balance any element, we have to place our number in front of each molecule. Here, and here, and here. Only we add a coefficient. Follow me? We already discussed this. Right. Now we want to balance the reaction. Okay? We need to balance the oxygen. Look here. We have to balance the oxygen. Right. Oxygen is here. We need eraser. Wait me. We need to balance our oxygen. Okay, follow me. This oxygen, the number of reactants is 1, and the number of products is 2. Which is smaller? Number of reactants are smaller. So we have to add a coefficient to this smaller reactants to reach our products, right? Only we can change the coefficients, means the number of molecules. So we can change only the number of molecules, but we cannot change the number of atoms. Be careful. So to get 2, I have to write here 2. To get here 2 times sorry, times 1. 1 means how many atoms are there? We will get 2. So we write here 2. Be careful. If we write here 2, our next molecule of hydrogen will change. Because of we write here 2. Oh, sorry. We write here 2. If we write here 2, our whole molecule will change. Overall, hydrogen will change and oxygen also. So, and here will be 2. So we write here 2 times 2. It will be what? 4. This oxygen is balanced now, but hydrogen is not. Look, another problem occur. Hydrogen is not balanced. This is 4. The other one is, this is 4. The other one is 2. So how to balance our hydrogen? Which is smaller? The number of products are smaller. So we have to add here another 2 times 2. We will get what? 4. We will get 4. Now let's raise here, clean. We will get here 4. So 4 is equal to 4. Yes, now. And here 2 is equal to 2. And oxygen is also balanced. So our chemical equation is balanced now. Okay. You can use this blank space to balance again. No problem. We'll take another one. Write the balanced equation for the reaction of molecular nitrogen and oxygen to form dinitrogen pentoxide. You will understand by writing. Nitrogen plus oxygen is equal dinitrogen pentoxide. Penta means 5 oxygen atoms. Right? First we write the number of elements in here. Nitrogen, oxygen, nitrogen, oxygen. So we have only nitrogen and oxygen. How many reactants of nitrogen are there? These are the reactants and these are the products. Number of reactants and the number of products. So we write here the number of molecules times the number of atoms, as we told before. Number of molecules are 1 times number of atoms of nitrogen 2. 1 times 2 is equal 2. And the products, number of products of coefficients of nitrogen is 1 also. We write here the number of molecules times the number of atoms. Number of atoms. So 1 times 2 is equal to 2. This 2 is the number of atoms. Is it balanced? The number of reactants is equal to the number of products. So 2 nitrogen in the reactant is equal to 2 in the product. So it's balanced now. Now we look at oxygen. The reactants here is oxygen because of this arrow separates the number of reactants and the number of products. You look the coefficient. It's 1 times the number of atoms of oxygen is equal to 2. This is 1 times 5 because of 5 atoms of oxygen. So 1 times 5. Oh, sorry. 1 times 5, right? So students, 1 times 5 is equal to 5. Is it balanced? No. Number of reactants in oxygen is not equal to the products of oxygen. So 2 of reactants is not equal to the 5. We have to balance oxygen now. Which is smaller, the reactants or the products of oxygen? the reactants are smaller. So to get 5 here, we have to multiply by what? If we multiply by 2, it will be 4. If we multiply by 3, it will be 6. So we can get only to multiply here 5 times 2 to get 10. And we multiply here 2 times 5 to get 10. So you think that which number will facilitate to get an equal number? So you will multiply that number. Now 10 is equal to the 10. Balance it. But we change here 5. We have to write here by 5 now, because of if we write here 5 in oxygen, this is, we write here 5 times 2, 10, and we write here 5. So we have to change here, not here, because of they are separated. But whenever we write here 2, we write here 2, and also here by 2, because of they are one compound. So 2 times 2 is equal to what? 4. Is it balanced? No. 2 is not equal to 4. Which is smaller? Here is smaller. We can change here into 2. So 2 times 2 is equal to the, what's problem? That's problem. So 2 times 2 is equal to the 4. 4 is not clear. So let us make it. Okay. 4 is equal to the 4. It's balanced again. Right. Our chemical equation is balanced overall. That's all today, students. Thank you very much. في أمان الله.